Now let us look at question number 14. For a set of four distinct lines in a plane, there are exactly n distinct points that lie on two or more of the lines. What is the sum of all possible values of n? Okay, I think for this question, you need to understand this phrase. There are exactly n distinct points that lie on two or more of the lines. Or therefore, in this case, can you see that for two lines, when they intersect, right, they will have a common point. Therefore, this is the point that they refer to. That means this particular point lies on two of the lines, right? Then can you see that? Can you see that? Let's say there are three lines in total. Then can you see that this point lies on two lines, and then this point lies on two lines, right? Or and okay, therefore in this case, ask ourselves this question: what is the maximum number of intersections for these four lines? Isn't that the maximum number of intersection is actually for the four lines you choose two, right? Therefore the to for you need for them you need two to intersect to get one point. Or therefore in this case, the maximum number of intersection is actually one. The maximum number of intersection is actually 4 choose 2, and in this case there will be 6 points. Therefore basically we are looking for the various possibility. That means for four lines, right? For four lines, the maximum number of intersection is actually 6. Can we draw this possibility? That means in this case, can you see that you have one line, right? And then you have a second line here, right? And then you have a third line here, or you have a third line here. Therefore, in this case, can you see that three lines generate three intersection, right? Three intersection. Then now, to make it maximum, to make it a maximum of 6, can you see that you just need to draw a line? You just need to draw a line that passes through these three lines. Therefore, this will be 1, 2, 3. Therefore, you have 6 intersection, right? You have 6 intersection. Then, how do you actually get 5 intersection? Can you see that in this case, it can be like this, parallel, and then you have two lines like this. Therefore, in this case, can you see that will give you 5 intersection? That will give you 5 intersection. Therefore, in this case, can you see that what we are trying to say is that, can you see that now go back to this statement? There are exactly n distinct points that lie on two or more lines. Therefore, can you see that? Look at this particular point here. Look at this particular point here. Can you see that it lies on this line, and what else? It lies on these two lines, right? Then in this case, let's look at this point. It lies on this line and this line, right? And and can I say that okay, two or more lines, two or more of the lines. Therefore in this case, each one of them actually lies on two lines. And okay, therefore therefore let's look at another case. Okay, let's say you have four intersection. How do you get 4 lines? Okay, maybe in this case you will have this case, right? 4 intersection, like this, right? And then and then let's say you look at 3 intersection. How do you get 3 intersection? Therefore in this case, can you see that 3 intersection? Okay, therefore in this case, can you see that you have one here and then one here? Therefore, can you see that this one, 1, 2, 3 intersection, and this particular point lies on this line, lies on this line, lies on this line, or therefore it lies on 3 lines, right? Okay, therefore, 4 lines don't get you 2 intersection. 4 lines don't get you 2 intersection, or therefore you don't have 2. Then let's say, what about 1 intersection? 1 intersection is basically this. Can you see that? Can you see that this is the point of intersection? It lies on this line, this line, this line, and this line. Therefore, in this case, total, there's only 1 intersection. 1 intersection. Then, can it be 0 intersection? That means 0 doesn't make sense. 0 doesn't make sense. Because it says that we are counting exactly n distinct points that lie on 2 or more lines, or 2 or more lines. Therefore, in this case, can you see that when you consider this case, actually it doesn't fulfill the criteria of the question. It means all the 4 lines are parallel, therefore you get 0 intersection. But this is not what the question wants. This is not what the question wants. Therefore, in total, the required number is actually 6 plus 5 plus 4 plus 3 and then plus 1. Therefore, in this case, the answer is 19. There are 19 distinct points that lie on 2 or more of the lines. There are 19 distinct points that lies on 2 or more of the lines. Yeah. Okay, with that, I stop here. Yeah.